just in general the scientific method, and I introduced you to matter. I'm going to go through more detail about matter. This is probably going to be broken up into more than one video. I don't know if it's going to be 2 or 3, but we'll just have to see how this plays out. All right. When you're done with this, you should be able to do homework 1, and I'll talk about that at the end. Well, you'll be able to do homework 1 at the end. So let's go through this set of slides. So matter is, as I said in the last set of slides, matter is anything that takes up space. Is stuff. So you can say that the universe, as we said in the last set of slides, is made up of 2 things. There's the stuff, and there's the space in between stuffs, matter and empty space. It's true, it's oversimplified, but it's true. Chemistry is the study of matter and its interactions, how stuff interacts with other stuff. So let's look at the nature of stuff. Right? So in the sciences, what we typically do when we come up with a theory is a theory. Another way of saying theory is a model. It's a way of looking at things, and learning how to think like a scientist will take you a long way in science classes. So we talked about this already. Matter is anything that has mass and occupies space, and it's made of tiny, tiny fundamental particles, and we'll talk about what those particles are as we move forward. By the way, these slides are appropriated from one of my colleagues. I just kind of stole some of her slides and tweaked them. All right, so one way of looking at it is what's called the kinetic molecular theory. And this is usually used to describe gases, but let's talk about this. So all matter consists of tiny particles, as we said, and these particles are in constant motion. So when you look at something like a table, you say that table is made of particles that are moving around. Well, to think about it in a little bit more detail, there's really only 3 kinds of motion. There's vibration, which is just what it sounds like, just kind of shaking. Rotation is spinning on an axis. And translation is when a particle moves past other particles. So if you take a particle and you move it from point A to point B, that would be translational motion. And then particles move in straight lines until they collide. And of course, what do they collide with? They collide with other particles. And it actually relates to temperature. The warmer it is, the faster particles move. All right, so you can think of everything as being made of little particles that are moving about, but either vibrating, rotating, translating, or all 3, and they move in straight lines until they bang into another particle. Now, a sign of a good model, a good theory, is it can explain stuff that really, really happens, right? It's kind of the idea of testing a hypothesis, but even when it's a theory, we continue to test it. So it should be able to explain nature. So to do that, let's go and let's talk about the 3 states of matter. Now, what I want you to do is hit pause here and maybe jot down on a piece of paper, just in your own words, and this isn't something you would turn in, but what is a solid, what is a liquid, what is a gas? Just describe them. Don't look it up. Just describe what's a solid, what's a liquid, what's a gas. So just kind of jot that down, give yourself a moment, hit pause. All right, so I'm assuming that you've done that. So let's go through what they are. So this is kind of a description, a nice picture. This is what a solid looks like. This is a liquid, this is a gas. This is a summary slide, but let's go into this. So a solid is something that, or you think of a solid as something that's hard, and a solid has a definite shape. So if the solid was a cube, if I put this cube into a great big round container, it would still be a cube. If I take this cube and put it out just on the table, it would still be a cube. So no matter what the container looks like, the solid is going to have a definite shape, right? Another thing about a solid is it has a definite volume. So if I took this cube right here and I put it in a 15-gallon container, it still would only take up the same amount of space, no matter what size container I put it in. If I put this in a 5-gallon container, it's only going to take up this much space. So whatever the shape is, it doesn't change. Whatever the volume is, it doesn't change either. Also, you can't squish them. So compressibility means you can squish it. You can't really squish a solid. They're not compressible. Those are good descriptions of a solid. Now, why is that? Well, it's because the particles are really, really close together. If you think about it, you can't compress the particles themselves, but you can compress the space between them. So if I have 2 particles that are really far apart, I could push them together. But if the particles are already touching, then I can't really move them closer together. And so the particles in a solid are really, really tightly packed, right? And then they pretty much only have vibrational motion. So next time you're in a really, really crowded place, like you're standing in line to get into Costco these days, or you're waiting to go, you're not going to be in a crowded place with 6-foot distancing, but eventually you will. And just think of it, if you've ever been shoulder to shoulder, that's what it's like to be a particle in a solid. They can't even spin around on their axis, right? They only vibrate. And they also stick to each other very strongly, and we'll talk about that a little bit in a moment. Right, so let's think about a liquid in these terms. Liquids, if I take a liquid and I had it in a cylindrical container like this, if I poured it into a glass that was the shape of a cube, what would the shape be? Right, it would have the shape of the container. If I poured it into an elliptical container, it would be elliptical. If I poured it into a cone container, it would be conic. So no matter what the shape, the liquid takes on the shape of the container. But the volume is definite. If I have 100 milliliters of liquid and I put it in a 15-gallon container, it still only takes up 100 milliliters. Right? So liquids can change their shape, but they can't change their volume. And you can squish a liquid a little bit. They're not very compressible. Now, let's think in terms of why a liquid can change its shape. What does it take to change its shape? And the answer is, to change shape, the particles have to be able to move past each other, right? So if you're just sitting right now, take your arm and lift it over your head. And if you do that, what's happened is the particles in your hand have moved past your head, and so they move past each other, right? That means that they have what type of motion is it where the particles can move past each other? That's right, they have translational motion, they also have rotational, so they're relatively free to move. Now, at the same time, the liquid particle right here doesn't go way up here, right? And why is that? Well, that means that what prevents it from going here? There's no particle in its way, and the answer is, well, it must be sticking to it. So they are still held together. So the particles stick to each other, but they can move past each other. So imagine if you're in a room and you can walk around, but you always have to be holding somebody's hand. That would be what it's like to be a particle in a liquid. Right? Now, in a gas, right, does a gas have a definite shape? If I had a gas, if you hold your hands like cup them together, there's gas in your hand, and let's say it's round. If I open it up, now the gas can go anywhere in the room, so it's the shape of the room. If I put the gas in a cubic container, it would be cubed. So it's whatever shape the container is. And if you think in terms of the volume, to give you an example, if you smell something, it's a gas. So if you had a little cup of skunk juice and you opened it up, people in the back of the room would eventually smell it. That means it's going everywhere in the container. So they are the shape and volume of the container. Gases don't have their own shape. And gases are very compressible. If you've ever used a hand pump, you know gases, you can squish gases big time. Now, what does that mean in terms of the particles? Well, that means the particles, indefinite shape, it can change shape. So what does that mean? That means the particles can, that's right, they can move past each other. They have all three types of motion. Now, in a liquid, the volume doesn't change because the particles are sticking to each other, right? But a gas, the volume can change. So what does that mean? It means the particles really are very far apart and they do not really stick to each other. In fact, when the gas particles start to stick to each other, what happens? It turns into a liquid. So a gas particle, each gas particle behaves as if it's the only particle in the container. So what I want you to see is, if we go back a couple of slides here, hang on. This is a good summary. So in a solid, particles are very close together, right? They're vibrating and they're stuck to each other really well. They have very, very strong interactions. In a liquid, they can move past each other, but they still interact. And in a gas, they can move past each other and they do not interact. All right? So that's solids, liquids, and gases, but in terms of kinetic molecular theory. So I would want you to be able to explain why a liquid can change its shape and a solid cannot. Why a gas can change its volume and a liquid cannot, but in terms of the particles. Now I'm going to stop here before I go on to this slide, right? Because this is a good stopping point. So I'm going to stop here. I'll pick up here on video number 2. I'm trying to keep the videos somewhere in the 10 to 12 minute range. I'm not quite at 10 minutes, but we'll go ahead and stop